Hello, welcome to this webinar about MS Skulebas. My name is Celine Solstad and I'm a technical advisor in Ocean Highway Cluster. For those of you who are not familiar with the cluster, we are a network for hydrogen and ammonia solutions in the maritime industry. We see a lot of hydrogen projects that do not make it from the PowerPoint slides. And with this webinar, we will get some insight into a project that is moving forward with installation of fuel cells as the first of its kind. We are very happy that we have gathered the project participants from MS Skulebas. And many of the presenters here today are cluster members. And we are arranging these webinars to share knowledge both from and to our members, as well as non-members. The webinar will also be recorded and will be available at a later point. We assume that you might have any questions during the presentations. At the end of the webinar, we will have a Q&A session, and the agenda is shown on the screen. You can insert your question using the Q&A function at the toolbar. All participants are muted by default, but if you want to speak up in the Q&A session, you can raise your hand and I can change your settings so you can talk. With that said, I think we just move on to the first speaker, Stig Antonsen, the project manager of MS Skulebas project.
Yes.
So Stig,
thank you, Celine.
Please share your screen.
Can you see my screen now?
Yeah.
Yes. Yes, my name is Stig Antonsen. I'm a project manager during the purchase and building of MS Skulebas. I've been working on this project for 4 years now, and here you can see a picture of the vessel right before delivery in Denmark this summer. Skulebas is a training vessel for Måløy Upper Secondary School, and they had an old vessel that was more or less ready for change out. And this is the old vessel that will be 50 years next year, and it's now sold. And 4 years ago, they decided to build a new vessel, and the contract was signed with Hvide Sande 2 years ago on this vessel. That is 35.3 meter long, 9.5 meter wide, and 473 ton. It's very crucial for us that it's below 500 gross tonnage. That's simplified approval process with the governmental or the Norwegian or Sjøfartsdirektoratet and also DNV. And the vessel has a cabin capacity for 20 persons. It's for 12 students and teachers and catering personnel and stuff like that. It's going to do automatic long lining type of fishing, gill netting, one type of fishing, and trawling and fly shooting. That's the fishing operation that the student could be training on board. It's also state-of-the-art on navigation and for engineers and catering personnel for the students in Måløy that take that particular education. The area of operation is coastal shipping, and that's also due to rules and regulation to minimize the price of the vessel. And the owner and the owner is Vestland Council or Vestland fylkeskommune, and it's operated by Måløy Upper Secondary School. A little bit technical, on the one-line diagram, you can see it's a very state-of-the-art system. It's a DC grid on 750 volt on this vessel. And we have 2 electrical motors for main propulsion, and we have a bow and a stern thruster. So actually the vessel is also equipped with dynamic positioning system. So this feature make it simpler to integrate a fuel cell system for this vessel since we have a DC grid on board. And the vessel also have a pretty large battery pack for its size. It's around 1 megawatt. And also the charging standard we have on board, it's according to IEC 80005-3. That's the new standard that's used in all harbor in Norway, Bergen, Ålesund, and we have also made this or arranged this solution in the home port in Måløy. So the demand here is that we can charge the battery during night time when we go on. Most often we go on day trips, and during night time we can charge the battery from 0 to full again. And we have measured around 20 nautical miles in transit solely on battery we can run. Purpose of the project regarding hydrogen or alternative fuel. It's a day trip from home port with 0 emission and in general reduce emission from operation on long haul operations and training of future engineers and navigation officers in operation of 0 emission equipment and solution. That's just also operation and bunkering and stuff like that. Why did we choose hydrogen on Skulebas? In practical, there are 3 other solutions we can choose. Nuclear is not very realistic solution for this type of vessel or vessel at all. So I jump over that. Ammonia, access to green ammonia. As far as I can see, for now we don't have that in proximity of Måløy, where our home port is. And also the availability for ammonia fuel cell, I think it's a little bit premature still. And the existing genset on board is not prepared for ammonia, running on ammonia. So it's also given technology risk. Battery, weight and volume issues. It's going to be very heavy, and the cost also for this will be tremendous. So that was pretty fast out route. Hydrogen. There are available technology. We first came in contact with Corvus that have a fuel cell based on Toyota's fuel cell. It's the most produced hydrogen fuel cell in the world. And Hexagon Purus Marine have a proven technology for storage. We are not the first customer for this solution. And we have also Norwegian hydrogen that produce green hydrogen 1.5 hour drive from Måløy. And there are existing solutions for transporting hydrogen on road, on containers, or in road solution. Yeah. So we landed on going forward with hydrogen, and Hvide Sande teamed up with Corvus Hexagon for the solution. And we have later made a deal with Norwegian Hydrogen for delivery of hydrogen. For funding, we tried with Enova to get funding, but we didn't get anywhere there. The reduction of emission was too little, they said, to fund this special project. But there are another solution that's directly to Miljødirektoratet, the Norwegian governmental office for environment. And we get funding there for approximately 50% of the cost of the project. Here we can see a picture of, that's just a sketch of how we see how the storage bank and the fuel cell can be integrated on board. A little bit about emission and emission reduction on Skulebas. This is the calculation we used for applying for governmental funding. And if we put up an use of 24,000 kilo of hydrogen per year, we have a reduction of approximately 35,644 liters of diesel. So from a conventional vessel that used 215,000 liters per year, we have now, with battery and hydrogen, we have reduced this to 99,000 liters per year on this particular vessel. Yeah. And just a short wrap-up. Hydrogen stands as the optimal choice for MS Skulebas, serving as a range extender while ensuring day-to-day zero emission operations. Thank you for your attention.
Thank you, Stig. Very interesting. And for the next presentation, we will learn a little bit more about the technical solutions. So first out is Corvus Energy. Oh, sorry, Hvide Sande. That's correct.
Yeah, you can see my screen?
Yeah.
Yeah, good. Okay. Yeah, I think I was first up. My name is Mike. I'm a project manager for Hvide Shipyard. And I was a part of the outfitting process for Skulebas. And now I'm the project manager for this fuel cell retrofit. We are very pleased to have this project since we want to be one of the first movers in regards to alternative fuels. And the two first slides will be a short introduction of our shipyard, and then we will go directly to the Skulebas and fuel cell. Let's see if I can switch. Didn't it? Oh. Vestland, a small country in Denmark at the west coast. If you see to the picture to the right, we have our production facilities, and next to it we have a slipway. We are a company that work with various types of vessels. We got from new builds, retrofits for alternative fuels, and historical vessels. We also do a lot of crew transfer vessels, which come in from the North Sea and needs a quick pit stop. Yeah, this is some of our production facilities with a close look up. We have our slipway, we have our surface treatment sheets, and we have 8,500 square meters of production area. So this is what it's all about. Skulebas. Skulebas was delivered in the summer 2023. We have delivered a very versatile fishing vessel to the Vestland County. And as Stig mentioned, it is a very high-tech vessel, including the newest technology, regardless if you are officer on the bridge, engineer in the engine room, or going to be a fisherman in the future. As it can be seen from the specifications to the right, it's a hybrid vessel. We have conventional fuel to Scania gensets. We have the battery pack from Corvus. And we are now going to install the fuel cell Pelican from Corvus as well. So right now we are at what we call the design phase. The design phase is being taken care of by the Norwegian authorities and a recognized class society. we are using a stage gate model, which means we have 4 steps we need to pass before we can proceed with the installation on board. We have a development of a preliminary design. Stig showed you a very rough general arrangement, as you can see in the pictures in the bottom of the slide. We are now starting to do a more detailed design. All of this is being done in cooperation with some of our main contractors. We have Corvus, and we have Hexagon Purus. Then of course we have our system integrators. Since this is the first vessel being designed and having implemented a hydrogen solution after the keel have been laid, this is very new for the Norwegian authorities and the class authorities, which means we have to use 3 different sets of rules. We have what we call alternative fuels with flaming point below 60 degrees, IGF code, and then we have the IMO 1455, which is an alternative approval process. This process have actually also been done for the batteries, but since batteries is a more commonly used equipment on board vessels nowadays, this is a more easy solution to implement. And as we go forward, Stig also briefly mentioned about this. We have this current system set up, a single line diagram showing the 2 gensets from Scania, and then we have the battery pack. The main purpose on longer voyage or fishing hauls is that the genset will be the ground load, and then we have the battery pack that can either act as peak saving or give the optimal operation for the gensets. Going forward and having the fuel cells retrofitted, as you can see from here to the right, we will now have an additional fuel cell connected to the DC bus. It's a 700 voltage DC bus, so that means all our major consumers and power generation is connected to this one bus, which makes it more versatile and flexible system. And the fuel cell in combination with the battery will make it almost possible to make a 0 emission voyage, if not exceeding above 5 hours or so. As it is today, we have 4 different power modes in our power management settings. We have the semi-auto, which is the operator control mode, where the operator needs to decide what needs to be connected to the DC bus and what should be disconnected, and give the optimal load curve. When going into the battery mode, that is what you will call today almost 0 emission. If there's full capacity available on the batteries, and no more power is requested than what the batteries can supply, which is approximately 0.5 megawatts, then you can sail only on the batteries. Gensets mode, that's more primarily for longer voyage, doing fishing, where the batteries will act as a peak saver. The short DC mode, that is when the shore connection is connected to the vessel, but you will also get the benefit from the batteries, which will you can either charge on the batteries or use the power from the batteries if required. With this new fuel cell mode, we actually have the opportunity to, as mentioned, go 0 emission for several hours, but especially when going from and arriving to port, they will have the possibility to use the fuel cell as a ground load, and then the batteries will kick in as the peak saving or additional power generation, which meaning you don't have to start up a genset. The genset will then only be a secondary item if you either have a low state of charge or something else, the genset will kick in if additional power is requested. And what is the benefit when it comes to operation? you are able to operate, or Skulebas will be able to operate on alternative energy sources for more than 5 hours while maintaining the speed at 80% load. You can have zero emission from exhaust. The exhaust from the fuel cell is mainly water, but I'm sure Corvus can tell more about that. It will be able to comply with future regulations. We see in certain areas or smaller ports, there's a specific requirements that you either have to use shore connection or go down on the zero emission power generation. Students will be trained for more sustainable power generation on board smaller vessels. As Steve briefly mentioned, there will only be more projects like this in the future. Combustion engines is last year, and this is what the future will bring. With this design, you have the genset, batteries, and fuel cell. You still have the flexibility. It's not like as with a ferry. You don't have a certain voyage each day, so you can go out for several days, or you can go out on a daily trip. And for the daily operation, the batteries and the fuel cell might be sufficient. We are a family-owned company, and some of our core values is high credibility, satisfies customers, and that we have certified employees. We believe that alternative fuel will be more and more, so we are very pleased to be a part of this project, and we hope that we hope to see fuel cells being installed on Skulebas within the next year or so. If you should have any questions, then you can always contact our head of sale, David Birkveld, and see our contact details on our webpage. And the last slide I had is just a beautiful picture of the sunset in Hvide Sande. And I would like to say that with this retrofit, Skulebas will be able to train the fishermen, engineer, and officers of tomorrow. And of course, we are proud of being a part of such an innovative project. Thanks.
Thank you,
That's
Mike.
all I had.
Yeah, thank you, Mike. Very interesting to see a little bit more about the ship design. And next up, now it's Corvus Energy.
Thank you.
Please.
Then I hope my screen have been shared.
Yes.
Perfect. Thank you all for being here, taking your time to listen to us. My name is Håvard, and I will, together with Thor Humerfelt, present our Pelican fuel cell that we are using on this project. Corvus was founded in 2009 in Vancouver, Canada, and provide purpose engineer energy storage solution and hydrogen fuel cell for the ocean space. We have for over a decade been the pioneers within the industry and have today over 50% of the market share. We have delivered more than 850 projects and have more than 5 million running hours on the battery. And with more than 700 megawatt hour sold battery, we have a lot of data we can utilize. From 2020, we also started to work with the Maritime fuel cell system, which we will present today. Today, we have the headquarters in Bergen, in Norway, and we have factories in Canada, Vancouver, and Bellingham in the US, and sales office around the world. For Skulebas, we are delivering one of our newly developed products, the Corvus Pelican fuel cell. It's rated at 340 kilowatt, and as we saw from Mike in the previous presentation, it will be located on the deck in a deck house. We will now go into more detail about the fuel cell and the system itself. If you should start with the story of the fuel cell, Corvus fuel cell, it started in 2020 when we started to develop the technology together with Toyota. As one of the largest supplier of fuel cell system, we was in contact with them and decided to cooperate. We buy a mass-produced fuel cell from Toyota, which have more than 30,000 units produced. They have more than 10,000 cars worldwide in operation. And to go into the maritime industry, they have partnered up with Corvus. And we are supporting them and building up a safe and maritime version of the fuel cell. With our position as the market leader for maritime batteries, we have a unique route to the market. We are using the same integrators who are providing the batteries for the vessels, and also working directly with the shipyard and the owners. In this slide, you see we have listed some of our customers, and you have Vestland as the integrator for this project, and Hvide Sande is the shipyard we are supporting. And now Thor could take us further into the product.
Yes, pleased to meet you all. So we are saying, okay, you're buying fuel cells from Corvus, and why should you do that? So one of the unique selling points for Corvus is that we have a combination with both batteries and fuel cells. Next slide, if you could press. So basically, being a manufacturer of battery modules, but now also fuel cell modules, like you see here on the picture, we claim that we will know the inner secrets of both of these. So in terms of what the battery needs, but now also in terms of what the fuel cell needs. So with your particular vessel, you will have a requirement of what that particular vessel will need. And with these knowledges of both the batteries and the fuel cells, we can tailor an optimal solution for your vessel. And that means that we can participate, in the project through the design phase, and to be able to support the customers to find, the optimal size of the plants, but also to find the optimal use of these two in combination. So to do that, we have an operational, tool or basically a program that we call the co-pilot, that will do real-time optimization between the fuel cell and the battery to share the load between the two. And as you probably know, batteries, they are really keen on doing variable load, peak shaving, and can be really fast in delivering power, whereas the fuel cells are more keen of having stable load. So the program that will actually make these two things happen, as we call the co-pilot, is also a very important development of our program. So next slide, please. So some of the most difficult things of introducing hydrogen as fuel on a vessel will be safety. Most of you probably know the IGF code in terms of using LNG in vessels. But now we are, in a way, raising the bar because we are now introducing hydrogen as a fuel. And to do that, we need to make a system that will guarantee that the vessel is safe, the crew is safe, and that the public opinion also feels that this is a safe way of transport. And to do that, we have introduced what we call the inherently gas-safe system for fuel cells on ships. So if you press the next slide, Måløy. So what we show you here is the Pelican fuel cell cabinet, and inside you see here one of the enclosures, which is marked in blue. And inside of 4 of these enclosures, we have each of the 4 fuel cell modules. That means that the fuel cell module will always be situated into what we call an enclosure, as we show here, which is pressure safe and also filled with an inerted atmosphere. That means that once we put the fuel cells into use, we will then have made sure that air is evacuated and that these enclosures are filled with nitrogen. If an event should occur, an unwanted, unexpected event of some kind, if there is leakages of hydrogen, we will always make sure that this atmosphere is then so safe and so inerted that there will be no possible explosions happen. And then we monitor this atmosphere inside. We make sure that we measure hydrogen, if there is any. We measure oxygen, if there is any. And then we have safety systems that will be able to close down if something happens. That means also we have a high level of redundancy. So if one of those modules would be put out of operation, you will still have the other 3 to work on. And that gives you a high level of redundancy also for the vessel. But the inherently gas-safe solution is really the most important aspect of bringing, what should I say, safe hydrogen systems on ships. So next slide, please. So what do we bring into the equation from Corvus? We claim that we bring marine expertise. So if you press the next slide. So what we say is that knowing the batteries, because that's been our main purpose of business for many, many years, bringing batteries and different batteries and energy storage systems to the shipping world. We are now also launching, the fuel cells into the market as well. So to do that, we have now a full-scale marine test site here in Bergen, and we invite all interested parties to come here and have a demonstration because we are really happy to show. In that test site, we have what we call a marine simulator, because in here we can do a full simulation of what a full-scale vessel system would work like. And to do that, we have installed a 340 kilowatt Corvus Pelican, as we showed on the previous slide. We have 100 kilos of compressed hydrogen where we run the systems. And we also have 16 Orca battery modules also installed on this site. And that gives us the full possibility to do a full-scale simulation with the batteries and the fuel cells in operation towards a load bank. So the load bank will then do the simulation of the propeller load or the hotel load or whatever load you have on the vessel, and we can run the system in full operation. To do that, we have brought in a full team working both with batteries, but now also 25 people working in the fuel cell development alone. Everybody is recruited with marine DNA background. So we say that the marine expertise is really what's bringing you a guarantee that we should be able to give a full, what should I say, ship-shape system for the future as well. So the factories for marine batteries, as Paul Ove was explaining, we have both in Bellingham, in Vancouver and Bergen, but we now also have a fuel cell factory location here in Bergen at Midtøy. So next slide, please. So as a summary, we have now gone through the various aspects of why we believe that fuel cells from Corvus could be a really nice option together with batteries. Basically because we have proven technology based on the Toyota systems. They actually have 15,000 development engineers and have been working on fuel cells since 1992. So quite a professional environment for that. But now also we bring this into the marine world. And we say we have a unique route to market, basically because we also have the experience and the background to work with more than 50 marine electrical integrators with the batteries, and that there is a good, what should I say, combination with bringing the fuel cell products into the market together with the batteries. And that gives a unique combination. Basically because we know the inner secrets and the wishes of both those two products to be able to tailor a best solution for the future market. To take care of the safety, we have the inherently gas-safe design, which should ensure that no unwanted occurrence of any kind should happen. Inherently gas-safe also gives you a much simpler installation on a vessel, basically because the system takes care of itself and requires very little changes or modifications to the ship. So the ship owner has great flexibility to be able to install these systems wherever he likes on the ship. And as, what should I say, a common denominator, we have the marine expertise to make sure that we should know the requirements for the ship owners and to be able to make good solutions that fit the marine world. So with this, we would like to say thank you very much for being able to getting into Skulebas and to support the systems for Skulebas. So while presenting, yes, follow that press. Next slide, Ola. Follow that.
It's
stuck, yeah. So we said that during these 7 minutes, we have saved you something like 1,100 liters of diesel and something around 4.4 tons of CO2 based on the emission reductions from the products from Corvus. So with this, we would like to say thank you very much for your attention.
Thank you very much. The next speaker is also technical for this technical solutions, Hexagon Purus Maritime.
Thank you. Can you hear me? Is it okay?
Yeah.
Okay. I will present from Hexagon Purus parts of the hydrogen storage solution which is chosen for the Skulebas project. We're happy to be invited and happy to learn from the wider audience. I think at the moment maybe 60 persons is looking into this webinar. So glad that you are into and interested into our solutions. Now, what is going to happen on this ship and what is the delivery from Hexagon? The intention and the scope from Hexagon Purus Maritime is to interface with the bunkering system, how to get the fuel on board. And also we include in our scope, we have also the pressure reduction regulators. So we prepare the hydrogen to a relevant pressure to distribute the low pressure hydrogen to the Corvus Pelican fuel cells. I think the pressure level is 8.5 till 9 bar, something that's the supply pressure to the fuel cells. Hexagon Purus provide solutions based on lightweight carbon fiber fuel tanks for automotives, aerospace, railway and off-highway vehicles already in a wide portfolio across the world. In America and in Europe, different types and different rules and regulations are present. We have solutions for most of them. What is new now is to base solutions from this portfolio to create a maritime fuel tank solution, storage solutions. The carbon fiber tanks that Hexagon make in the different factories in Germany and in America at the moment, compared to a steel tank, our solution weight is around 25 to 30% weight of equivalent in steel. That means it's a lightweight solution. It is very redundant and agile and non-corrosive due to the material selections. We're also very good fatigue strength and leak-free solutions, which is relevant and necessary for high-pressure hydrogen storage. Our maritime team is located in Ålesund. Most of our employees are either ship design, shipyard, and mechanical and electrical background, all of us. So our role is actually to prepare maritime tank systems based on the core production tanks from the different factories in Hexagon. So that is what we do. And then we discuss with the ship designers and shipyards, how can it best be integrated into the ship based on the different solutions that we can configure and assemble. Now, this is an illustration for the first Aquafarm ship, a service ship to be built at Moen Verft at the moment. This fuel tank system is in our workshop in Ålesund at the moment. It's going to be delivered early next year to the shipyard up in north of Trondheim in Ålesund. That means this solution is actually the same Physically, it is the same tank type and the same valve and solutions. For this one is to be used on Skulebas. So Skulebas is a copy or very similar copy on this first delivery. Hexagon also developed and make the control system and the safety system to connect to the ship power management, battery management, and integrated automation system on board. So we are trying to help the shipyard interface and connect our systems as easy as possible using standard maritime communication protocols. This one is based on Modbus standard protocol. Now for Skulebas, using the different maritime tanks from our Hexagon portfolio, we find that to be capable of approx 114 netto usable kilogram of hydrogen gas, we can do it in different configurations. We can have 4 cylinders type Magnum, or 1 of the very big tanks, or 14 or 15 of the smaller type tanks. For this solution, we chose to use 4 tanks in the configuration that we discussed. And based on this one, we are preparing then a range extender solution for the retrofitting of Skulebas. And you already know that Corvus and Hvide Sande has already installed about 1050 kilowatt hours battery package on board. Now we are adding a system of 125 kilogram of hydrogen in addition. And when we think about 125 kilogram, which is half of 250, say through the output, electrical output from the fuel cell from Corvus, you will get about 2,100 electrical kilowatt hours in addition. That means that you already have 1 megawatt hour in electric battery available, then plus 2 megawatt hours more in hydrogen. So which means that she will have 3 megawatt hours zero emission capability, which is a significant increase of her capabilities. But most important thing is it is a training ship for the next generation future seafarers to climb on board. So we are really proud that we are part in this project together with you, because not only technology is important, but also we need to make sure that the future mariners and also existing mariners get the opportunity to learn and get acquainted with this technology and to learn about it in a safe way, how to operate and use it. So this is a picture from, I think it was in August. Skulebas was on her way. She passed Ålesund, and then we got an opportunity to climb on board to have a view. And then we found, well, certainly we will meet again. And we are happy to be on board. I am available for questions afterwards. Thank you.
Thank you, Håvard. Now we are moving a little bit further away from the technical solutions and over to actually where are the hydrogen coming from. So please, Norwegian Hydrogen.
Thank you, and thank you for inviting us. My name is Jørgen Kopperstad. I'm heading up the Maritime in the Norwegian Hydrogen. And it was really a great milestone for us yesterday when we were able to announce that we are a supplier of hydrogen to the Skulebas project. And as mentioned by many of you previously, this is very great, especially since this is a school ship, right? So as Håvard and Mike mentioned previously, this will educate the sailors to come for the next years, and that Måløy now has capability to educate the future sailors on these new fuels. That is amazing, I would say. So it's a very good project and very good work by Stig and the rest of the team developing this onwards. Norwegian Hydrogen, let's see, there it's working. We are building a complete value chain for green hydrogen in the Nordics, focusing on the development of green hydrogen production plants and distribution infrastructure. Comparing the predicted offtake of hydrogen in Europe in the years to come with the current production capacities, that really highlights the need of large-scale build-out of production plants and infrastructure. And it is very motivating to work together with my colleagues on contributing to the build-out of this. It is not an easy task, but luckily we are backed by a group of strong industrial owners. Knut Flak, the main owner of Flak Group, was the funder of Norwegian Hydrogen back in 2020, together with Hexagon, Hofset, and Hexagon Purus, Hofset, and Tafjord. And they positioned the company basically to deliver on our purpose. And a year ago, we were lucky to have the Japanese conglomerate Mitsui joining us, contributing a vast global network and resources. And as of October this year, we could finally announce a placement from Fortescue, contributing to the continuing growth of our company. This is how we prefer to illustrate how we look at the implementation of renewable energy in mobility. If you talk about hydrogen 10 years ago, you were a rock star in the maritime industry. Everyone like, wow, hydrogen is really the future. Then it was kind of, I felt that people realized that hydrogen is different from diesel, so they needed to look for something else. Then you have this ammonia wave, and you have this methanol wave, and now you have this nuclear wave as well. But basically, it's all the same. It's about direct electrification and how to get renewable energy on board vessels. And even though I work with hydrogen, I'm never trying to compete with batteries, because if you can use batteries, it's way much more efficient than hydrogen. So if you can use batteries, use batteries. But if you can't use batteries, you have to use the second best alternative, and that is hydrogen. But hydrogen as well has limitations due to range and weight and etc., mass and volume. So if you can't use hydrogen, then you need to look for some of the hydrogen derivatives. And to understand how all of this is connected is really important. And luckily, we are part of the Maersk Mc-Kinney Møller Center for Zero Carbon Shipping, where we are working a lot in comparing this and making this fuel available. And to understand that all of these hydrogen and hydrogen derivatives are connected through different biochemical processes, that is important. And in Norwegian Hydrogen, we are focusing on the green electricity and the electrolysis of water and how we can implement that in fuels. Not only hydrogen, but also derivatives. But the key point is the production of green hydrogen from green electricity. And it's also important to remember that all of these fuels can be combusted in various applications. You can't, for example, use hydrogen in both boilers, fuel cells, and gas turbines, and the same accounts for the others, naturally on different TRL levels. But this is the ship designer's most important work today, I would say, to kind of put together the most efficient powertrain that you can, given the current status in the market. And if you look worldwide, you see that it seems like the industry have understood this, because the focus is really now on the development of hydrogen production capacities, since that is needed. A fun fact is that 3% of the world's emissions today is the production of hydrogen. And out of those 3%, 1.5% is ammonia, hydrogen used to produce ammonia, and 25% is hydrogen used to produce methanol. Again, just a great example of how all of this is connected. So for ships considering hydrogen, is hydrogen really competitive? That is always an interesting discussion. And I often meet ship owners and designers that thinks that hydrogen as a fuel is way much more expensive than other fuels as well. And in some contexts, that may be true. But if we look at what the European Union now is doing through the ETS system, it's really easy to see that things are changing. We expect that the ETS will be at about 200 euros per ton by 2030. By 2040, it will be even higher. And that is needed to reach the ambitions set by EU for the maritime sectors and the industry in general. And given diesel oil price in Rotterdam by, say, $800 to $900 per ton in October, and a powertrain efficiency of a diesel engine of about 40%, That is a bit high, maybe, for supply vessels in the North Sea, maybe for fishing vessels and etc. And it's a bit low for deep sea transit vessels, but let's assume 40%. The cost of an electric kilowatt hour delivered to the switchboard on the vessel is about 0.33 euros per kilowatt hour. And that is given that the ETS goes to 200 euros per ton. It's not even implemented, but it's beginning to be implemented from January 24, right? So this is coming, no debate. This will be. If you then look at the hydrogen price that need to be compared to have the similar euros per kilowatt, it's 6.4, given a 50% powertrain efficiency of the fuel cell. And maybe that is a bit high in some contexts, maybe a bit low in other contexts, but I think it's, I think I'm getting the thumbs up from Corvus here, so let's assume 50%. So then you really see that hydrogen as a fuel within 5 years will be competitive to diesel. So then you can choose to go for diesel, who emits CO2, or hydrogen, who doesn't, and it's the same price. I haven't looked at the cost of the systems on board the vessel, only the fuel costs. And this is very important, and I think it needs to be considered when ship owners are buying vessels today. And it's apparently what Stig has already noticed. So for the Skulebas project, we are delivering the hydrogen from the Hellesylt Hydrogen Hub. The factory is located near the UNESCO World Heritage Area of Geiranger, where we have access to stranded hydropower capacity. A great example of a location where it's very, very suitable to produce hydrogen, since we have available electricity that can't be used anywhere else. And in cooperation with our partners and with grants from Innovation Norway and the Norwegian Research Council, we are currently building this plant with a daily capacity of 1.3 tons of hydrogen. The first production will be in 2024. This facility is quite near the main port of Skulebas. It's only 117 kilometers driving distance. And in these applications, it's always important to look at how far is it to transport the hydrogen. If it's very far and you need larger volumes than what Skulebas needs today, compressed hydrogen may not be the best alternative. But for this case, it's a very good alternative. It's produced nearby Måløy, not that far to drive, and it's stranded hydropower. So it's a good business case, I would say. So thank you for inviting us. And if any questions, do not hesitate to ask them. Thank you.
Thank you. So that was the last presentation, and then we are starting the question session. I have not seen any questions in the chat, but if any of you do have any questions, you can also raise your hand and speak up. I do also have some questions myself, but I think we can maybe see if it's any questions from the audience first. But so just write your answer either in the Q&A. You can also use the chat if that is better. Okay. We get a question, if Jørgen, if you could go back a few slides for the hydrogen competitiveness slide. I guess it's an answer. It's a question related to that.
I'll do my best.
Yeah.
There we are. Maybe someone has found miscalculation, and then I'm on rough edit, I guess.
So please, is it a question regarding this, or?
It's important to notice that there is a lot of assumptions, and it's not to be specific regarding this, but it's trend. The oil price is very volatile. The LNG price is very volatile. So it's very difficult to compare, but it's important to kind of, are we on the same page as fossil fuels? And that is what I'm trying to illustrate.
Yeah. Okay, I guess that's what was okay. I do have a question to Mike. When you originally built the vessel, you said it was a retrofit. Did you already then plan to kind of have a hydrogen system on board, or was it kind of a coincidence that it was suitable room on the deck?
Yeah, it was by coincidence. We didn't plan for it.
No.
Yeah, I think the one who got the idea was Stig, who discussed it with Vestland Fylkeskommune, and then we had to do a normal what's called tender for it, and then it's yeah. So by that way we got the contract.
Yeah, I understand. I also have a question for Corvus. I'm not sure who of you want to answer, but could you tell us a little bit more about the differences to having a fuel cell system on land and on maritime applications such as a vessel? What's the differences that you need to consider?
Answer, Paul. So I would
feel free.
Yeah, the biggest difference, Celine, will be in terms of safety. And so the safety system is absolutely crucial to, of course, get the classification by NMA and the class societies like DNV in this case, or any other one for that sake. But of course, that is absolutely vital in order to be able to sail the vessel, just to get the classification. But of course, also we need to convince ourselves, the customers, the public, and of course, to make sure that absolutely no incidents should occur. Secondly, I would say that to put fuel cells on a ship will require also a system which is heavy duty, which means it should last a long time. It should also be able to fit within the maintenance requirements of a ship. So typically we say that, okay, the reclassification of a vessel is every 5th year. And by that, we have to target that our system should also be able to last for 5 years before we need a major overhaul. So that is what we do. So we say typically 30,000 hours between overhauls, and that we base the overhaul philosophy on exchange pool system. So when a vessel needs overhaul, we will bring in new fresh models, and we will then replace those with the old ones, take the old ones back for refurbishment, and then we have those ready for the next round when a new vessel needs overhaul. And in that way, we should be able to keep high standards for the safety systems, but also to be able to react quickly and to ensure minimum downtime for the ship as well when the overhaul is done. I would say those two main things. So classification and security is one thing, and heavy dutiness in order to endure what a ship requires, because it's quite a big difference between a load from a ship and what you would have on a truck or something on a car.
Yeah, and also I guess that kind of is a question for you as well, Håvard. Is there any differences for your system on when it's on a maritime application and on land?
Yes, clearly there's big differences. Maybe the most important thing to remember is that on land there is 2 big differences. Is if it is a fuel tank on a truck or bus, or is it a distribution system, a cargo solution to be transported on land. That is the major differences on land. Now on ship is even more challenging because as Thor and the other guys already explained that there are special safety, additional safety requirements for ships, because there is not so much external help available in case of an incident. So you need to have more built-in safety features and solutions. So for instance, also if you're fueling or bunkering a bus or a truck on a standard land-based refilling station, all the intelligence and responsibility is on the refueling site. So the tank on a car is non-intelligent. It is to be ruled and managed by the fueling station. On ship, the fueling station will still need to be intelligent, but to be controlled in cooperation with the fuel management system on board the ship. Because the ship always needs to have the final saying in her own safety. So that's the big difference and need to be built in addition to corrosion protection, durability, agility, wear and tear, all these additional things. But it can be done. I just for fun, sometimes I say it's not rocket science, even if it is used in rockets. So
yeah. I think I will take just one last question. It's more about the students. So maybe Stig, you can answer that one. This is an educational vessel. So what will be the benefits for the students for using this vessel and kind of be a part of this new technology? How will they be hands-on the technology? Will they kind of just observe, or will they also be able to do the monitoring as well?
No, the thought here is that they should have training and of operating the system, especially bunkering procedure and the safety procedure, and maybe we can have course on board. You know, Vestland Fylke maybe will have another project with hydrogen, let's say passenger boats going up and down the coast. Then this vessel can be used for engineers from their point of view to have a bunkering procedure and stuff like that. So the whole idea behind this is all the students gonna be trained in bunkering and using the system, both for engineers and navigational officers. There are safety features there that they have to consider and stuff like that. So there will be a complete whole training program regarding the whole hydrogen system on board.
Yeah, I think that's a good way to wrap up this webinar. I just want to say thank you to all the speakers. Very nice of you to talk about the project and give us more details. And thank you also to the participants. Have a nice day.
You too.
You too.
Thank you.
Bye-bye.
Bye-bye.
Bye.
Bye.
Bye bye. Thank you.